So next problem is we need to prove that 1 by secant a plus tan a equal to secant a minus tan a. That's the next problem we need to prove here. So let us take the left hand side LHS 1 by secant a plus tan a. So once if you observe this problem, children, so you should be able to think that we need to do the rationalizing the denominator. So what do you mean by rationalizing the denominator? Rationalize the denominator means if this is a plus sign is there, we need to multiply the numerator and denominator by secant a minus tan a, secant a minus tan a. That is, if this is a plus sign is there, we have to multiply secant a minus tan a. We need to change the sign. That is called as making the denominator the rational number. That's called as rationalizing the denominator. So after this, we need to start simplifying the problem here. That is secant a minus tan a divided by secant a plus tan a into secant a minus tan a. Children, so you should need to understand this is a formula of a plus b into a minus b. Again, we need to recall that a plus b into a minus b, that is a square minus b square. So secant a is a and tan a is b. So secant a plus tan a into secant a minus tan a is secant square a minus tan square a. That is a square minus b square. That is the formula we are using. A plus b into a minus b is a square minus b square. That is secant square a minus tan square a. So you should be able to come back to again to the trigonometrical identities. That is secant square a minus tan square a. What is secant square a minus tan square a? So you should be knowing that secant square a minus tan square a is equal to 1. This is a trigonometrical identity. Secant square a minus tan square equal to 1. So we are going to get secant a minus tan a divided by 1. So secant square a minus tan square a is nothing but it is 1 it is. So we got the RHS, that is secant a minus tan a. So that is nothing but equal to RHS. So hence we have proved that LHS equal to RHS. LHS equal to RHS. So this is how we have to solve this type of a sum. Like the concept here is, the main concept is rationalizing the denominator. If this is a plus sign is there, we have to multiply secant a minus tan a. If it is a minus sign is there, we should write secant a plus tan a if the problem is like that. It depends on the problems to problems here. So then we are going to use the next identity is secant square a minus tan square a. That you should know it is nothing but equal to 1. So that's how we got the RHS. So we'll move on to the next problem here. That is secant a minus tan a by secant a plus tan a is equal to 1 minus 2 secant a into tan a plus 2 tan square a. So this problem is again a similar type of a sum. What we did in the previous problem is a similar type of a sum. It's again the same thing. We are going to do the rationalizing the denominator. So let us take the left hand side. LHS secant a minus tan a divided by secant a plus tan a. Again rationalizing the denominator. The plus sign is means, as I explained in the previous problem, if it's a plus sign, again we have to multiply by numerator and denominator by secant a minus tan a. If it's a plus, we have to write as minus here. Secant a minus tan a by secant a minus tan a. So that is called as rationalizing the denominator. So you please observe very carefully the numerator part. Secant a minus tan a, secant a minus tan a. That is nothing but, you should understand that it is nothing but secant a minus tan a whole square. This you need to understand. That is nothing but a minus b into a minus b. Like if you are going to use that, a minus b into a minus b. It is nothing but a minus b whole square. So it is like adding the powers. adding the powers. 1 plus 1, it is 2. The same thing we are applying for this numerator. Secant a minus tan a into secant a minus tan a is secant a minus tan a whole square. The denominator is again a similar type. It is a plus b into a minus b. It is again we are going to write as secant square a minus tan square a. Again we are going to use the same formula, a square minus b square. In the previous sum just now we did, it is a plus b into a minus b is a square minus b square. Here we are using secant a as a and tan a as b. So it is a square means secant square a and b square means tan square a. So again the same formula, identity, secant square a minus tan square a is 1. So what we'll write here, secant a minus tan a whole square. So divided by 1 because secant square a minus tan square a is 1 it is. Now we need to observe the RHS. Whenever we are proving this, we should be always observing the RHS also. Here we got secant a minus tan a whole square, and what we should do is a very important question comes. So we need to observe again the algebraic identity, that is a minus b whole square. It is a square minus 2ab plus b square. This is actually algebraic identity we are using here for this. A minus b whole square formula. Here secant a is a and tan a is b it is. So here a square means secant square a minus 2ab. 2ab means 2 secant a into tan a is minus 2ab plus b square. So b square means is tan square a. Tan square a. You can understand this, I feel everybody can understand very easily. It's a square minus 2ab plus b square. It is in the form of a minus b whole square formula. So secant square a minus 2 secant a into tan a plus tan square a. But we need to prove 1 minus 2 secant a into tan a plus 2 tan square a. It means to say that we don't want secant square a. Here we don't want secant square a at all. We don't require the secant square a. Then what should you write for secant square a is very important. So we should write the secant square a as 1 plus tan square a. Why should we write means we don't require secant square a in RHS. That's the reason, children. So you should need to understand that. That's a very important thing. We should observe and then you should think about what should you write for secant square a. It is nothing but 1 plus tan square a. It's a identity, trigonometrical identity. And as it is, we should write this minus 2 secant a into tan a plus tan square a. You can observe very clearly it is tan square a plus tan square a. 2 tan square a you will get. And first we will write 1. 1 will write, we rearrange the terms. 1 will write minus 2 secant a into tan a. Tan square a plus tan square a. It is 2 tan square a. So children, you can observe very clearly it is RHS. So it is RHS. So we have proved LHS equal to RHS. Again, it's a similar type of a sum of previous sum. But what is the change in this means we need to observe is we are applying a minus b whole square in this. That's the change from previous problem to this problem. So I hope you understood this problem. The next problem is sin a plus cosec a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square. So children, you need to think about the left hand side here, because here if you all observe it is a plus b whole square you have to observe, because here you cannot use that formula a plus b whole square plus a minus b whole square. It is not a minus a, and of course here a is sin a and here it is cos a. So for both these terms you have to use a plus b whole square and a plus b whole square. So let us start with taking the left hand side, LHS. Sin a plus cosecant a whole square plus cos a plus secant a whole square. So let us take this. This is a plus b whole square here. We are going to apply that formula. The formula you should be able to remember, all of you. A plus b whole square is a square plus 2ab plus b square. So this is the formula you need to apply. So it is sine square a plus 2 sine a into cosec a. That is a plus b whole square. That is a square plus 2ab. That is 2 sine a into cosec a. It is plus cosec square a. Cosec square a plus, so you can use a square, that's the formula we are using here, a square plus 2ab plus b square. Here b square is cosec square a, and here it is again a plus b whole square formula. Here a is cos a and b is secant a. So what should you write here? Cos square a square means cos square a plus 2 cos a into secant a. 2 cos a into secant a. This is the formula generally, so you should make it in a box, you can write it. That is 2 cos a into secant a plus b square. Plus b square means it is secant square a. So this is actually a formula we applied, a plus b whole square formula. Sin square a plus 2 sin a into cosec a plus cosec square a. And here also a plus b whole square formula, cos square a plus 2 cos a into secant a plus secant square a. So now let us come back to the what we need to prove it. The proving part is very important for us to observe. 7 plus tan square a plus cot square a. So if you observe, all of you, very carefully, you need to observe sin square a is there, cos square a is there. So we need to arrange the terms. So I hope all of you are remembering the identity. Sin square a plus cos square a, because all of you know sin square a plus cos square a is nothing but 1, plus again we need to observe this 2 sin a into cosec a, and here also you need to observe 2 into sin a into cosec a. Sin a into cosec a is 1, that also you should know very well, sin a, because reciprocal of cosecant a is 1 by sin a. So sin a into cosec a is 1 it is, that's what I have written here. And plus cosec square a. Actually in RHS we don't require this cosec square a. So what should you write for cosec square a? Again you go back to the identity, trigonometrical identity. The cosec square a can be written as 1 plus cot square a. So that is what we need to write, cosec square as 1 plus cot square a. That's a very important thing you should know, all of you children. Plus, again we have to come back to this part here, cos a into secant a. Again cos a into secant a is 1. This is very important to understand, all of you. Cos a into secant a, because cos a is equal to 1 by secant a. It's again a reciprocal relations. Cos a into secant a, cos a into secant a equal to 1. That's the reason I am telling you cos a into secant a is equal to 1. So that's what I am writing here. Cos a into secant a is 1. So plus 2 into 1 plus, so secant square a. Again we don't require secant square a here. So what should you write for secant square a? Again you have to go back to the trigonometrical identity. Secant square a can be written as 1 plus tan square a. So I hope you are clear with this identity. Secant square as 1 plus tan square a we used, and cosec square as 1 plus cot square a. Now we need to simplify this. The simplification is sin square a plus cos square a is, again it is 1 plus 2, 2 into 1 is 2 plus 1 plus cot square a plus 2 plus 1 plus tan square a. So you just have to add 1 plus 2, 3, 3 plus 1, 4, 4 plus 2, 6 plus 1, 7. So we are going to get 7 plus, we need to arrange the terms according to what we require here, that is tan square a. We will write plus tan square a plus cot square a. So hence we have proved, that is LHS equal to RHS. It is 7 plus tan square a plus cot square a. That is LHS is sin a plus cosec a whole square plus cos a plus secant a whole square is nothing but, we have proved it as 7 plus tan square a plus cot square a. That is nothing but what RHS we have proved it. I hope it is clear, children. Okay, so this is how you need to solve these type of problem like this. Okay, let us move on to the next type of a problem here. When you all observe 1 divided by 1 minus sin A plus 1 by 1 plus sin A is equal to 2 secant square. 2 secant square. So this problem, when you observe very carefully, children, so you should be very careful to understand a plus sign is there here. Here plus sign is there means we should take always a LCM. That is very important. So first let us take the left hand side LHS. That is 1 divided by 1 minus sin A plus 1 divided by 1 plus sin A. This is your the left hand side. Whenever I just want to make it very clear to you children, if it's a plus sign or minus sign, you should always take LCM. So let us take LCM. So what is the LCM here? 1 minus sin A. 1 minus sin A into 1 plus sin A. So this is your LCM children. So once we take a LCM like this, 1 into 1 plus sin A. That is 1 into 1 plus sin A is 1 plus sin A. That's what LCM concept I have explained you in the previous my video, that how to take LCM. So it's the same thing, 1 into 1 plus sin A plus 1 into 1 minus sin A is 1 minus sin A. So plus sin A minus sin A will get cancelled, no children. It's a very simple thing. Just plus sin A minus sin A will get cancelled. 1 plus 1. 1 plus 1 is 2. And you can observe children very carefully. 1 minus sin A into 1 plus sin A. It is nothing but 1 square minus sin square A. It is again A square minus B square. A minus B into A plus B. It is A square minus B square. That's a formula. You have to be very perfect. So that is equal to 2 divided by 1 square is 1 itself. 1 minus sin square A. What is 1 minus sin square A? It is cos square A. 1 minus sin square A is nothing but cos square A. That is the identity. We should be very clear, children. 1 minus sin square A equal to cos square A. This is an identity which you already learned. And one more thing. Now we have to see the RHS. We need a secant square A. Very clearly, 1 by cos square A. Children, you should be knowing that cos A is nothing but 1 by secant A. So 1 by cos square A is nothing but what? It's a secant square A. So it is 2 secant square A. It's again a reciprocal relation, children. Since it is a cos A, it is 1 by secant A. If it's a cos square A, it is 1 by secant square A. So here it is 1 by cos square A. So we should write as secant square A. Secant square A, that is nothing but RHS, 2 secant square A. So that is RHS. So children, we have proved LHS equal to RHS. So this is how we need to prove whenever you get a problem like this, if it's a plus sign or a minus sign, the first thing what you should do, children, you should take LCM and start simplifying the sum. Then you should start using the identities. That's a trigonometrical identity, algebraic identity. You have to think according to the problem and go ahead with the problem. So the next problem is we need to prove that 1 minus sin A by 1 plus sin A equal to secant A minus tan A whole square. This is quite a little bit different problem I have taken for you children, because it is not like other problems, a very direct problem it is. I think you must be observing here it is secant A minus tan A whole square is there, here it is 1 minus sin A by 1 plus sin A is there. So how to go on with this type of sum? Of course, every time what we do means we take a left hand side and do the rationalizing the denominator and we used to go. Of course we can do it. So this time let me do some change for you. Let me take a right hand side now. Let me take a right hand side and prove the left hand side, children. Because till now I was solving the sums by taking the left hand side and proving the right hand side. Let me take the right hand side and prove the left hand side. This is also quite easy, but you need to think again, children. So now let us take a right hand side RHS. That is secant A minus tan A whole square. Please don't forget this whole square, children. Many of them I observe they will forget of this square itself. They will be simply writing it. So now you have to think about it. You've got a lot of options here for you people, children. You may be thinking I should use a minus b whole square and write a square minus 2ab plus b square. But if you are going to do that way, are you going to get the left hand side, children? You need to observe that very carefully here, because you have to think about the sum, because it's not simply solving immediately, taking a minus b whole square and solving the sums. So what we should do for this means, for this type of problem like this, we need to write what is secant a is nothing but 1 by cos a. This is the reciprocal of secant a is 1 by cos a minus, and tan a is sin a by cos a. So you need to observe whole square. Please keep in your mind that whole square has to be there here. Don't forget it. And you can see I have taken reciprocal relations. Secant a is 1 by cos a, and this is a quotient relation. Children, you should be knowing very well. Tan a is sin a by cos a. And whole square as it is, I have written it. Now after this step, I already explained to you in the previous sum, whenever a plus or minus sign is there, we should take LCM. So LCM is very easy for you because denominators are same. So directly we can write this as 1 minus sin a by cos a whole square. So what I written here? I written directly 1 minus sin a by cos a whole square, because cos a is common. So I have written cos a and 1 minus sin a as it is written. That's the LCM concept I have written, children. And whole square, of course, is very important. You should write that. And now let me use this square for both numerator and denominator separately. So you may be asking why? Because you have to observe again the left hand side here. 1 minus sin a by 1 plus sin a, we have to do it. So what we should write here? 1 minus sin a whole square divided by cos square a. What I did here, I have taken a square for numerator as well as what? Denominator. This is a very important step, children, so you should need to understand here. 1 minus sin a whole square by cos square a. And you know that we are almost coming near to that left hand side. We are 1 minus sin a by 1 plus. Not exactly, I am just trying to tell you how we are going to the left hand side. Now again, cos square a. What is cos square a? Again comes the question for you. Cos square is nothing but 1 minus sin square a, children. So you should be able to remember that. 1 minus sin a whole square will write as it is. As it is, will write numerator. Denominator is cos square a is 1 minus sin square a. That's very important, children. So you need to understand that cos square a is 1 minus sin square. That's identity again here. So that is equal to 1 minus sin a whole square. I will write as it is. And here you can observe, children, it is a square minus b square formula again. A square minus b square, because it is, why should you use a square minus b square? Means because we need 1 plus sin a here and we need to apply here. It is 1 plus sin a into 1 minus sin a. This is a formula. A square minus b square is a plus b into a minus b. So after this, you know very well, all of you, 1 minus sin a and 1 minus sin a will get cancelled here, because we are cancelling 1 minus sin a. So what are you going to get? 1 minus sin a by 1 plus sin a. So this is actually a left hand side, we got it. So this is a LHS. LHS. We have taken the RHS, right hand side, and we have arrived with the LHS, that is 1 minus sin a by 1 plus sin a. So therefore RHS is also equal to LHS. Hence we have proved it. So children, so there are so many ways of solving the sums, but it is your idea. The idea is very important. Your thinking is very important. When you start solving the sums only, you will get it. You will get it. Definitely. Please do more and more problems. Definitely you will find it very easy with the problems. Once if you are clear with the problem, automatically you will do very well, children. Okay, let me take next problem here. Tan square a minus tan square b equal to sin square a minus sin square b divided by cos square a into cos square b. So it's very important to observe, children. We have to take the left hand side, because the right hand side is sin square a minus sin square b by cos square a into cos square b. So we are not able to take the RHS and do the LHS. Of course, if you do little bit simplification, of course you can do. But the first thing we get in our idea is tan square A minus tan square B, because tan A is sin A by cos A and tan B is sin B by cos B. So that is the reason we'll take left hand side. LHS, to prove this problem, LHS is tan square A minus tan square B. This is the left hand side. So tan square A, what is tan square A? It is nothing but sin square A by cos square A minus tan square B. It is sin square B by cos square B. So we use the concept of tan A and tan B. Here angle B is there. Please don't forget to write this B. Sin square B by cos square B. Here A is the angle is different. Sin square A by cos square. These are small things. The small things you have to be very careful. Because I have seen many of them will write here A means they will write here also A. That's going to be wrong for you. So because angles are different. So be very clear about this. Okay children, next. When I say the minus or plus, what should you do it? Should take LCM. That's a very important concept. Taking LCM. So what's LCM here? That is cos square A into cos square B. This is the LCM which will be very important. Cos square A into cos square B. And you know how to take LCM, which you learned. Sin square A into cos square B. Sin square A into cos square B minus the same way sin square B into cos square A. Sin square B into cos square A. I hope you are clear with the LCM here, all of you children, because this LCM is sin square A into cos square B minus sin square B into cos square A. And of course, the denominator we already got. We also have to observe the RHS, right hand side. RHS is what? Cos square A into cos square B. So definitely we already got the denominator part. Now we have to observe the numerator part. The numerator part is what? Sin square A minus sin square B. So here we are having sin square A into cos square B minus sin square B into cos square A. So what is the problem we are facing children? Here we are facing the problem is we don't want this cos square B. We don't want this cos square A. We want only sin square A minus sin square B. So we need to remove this cos square B and sin cos square A we don't want. How to remove this? This is a very important for all of you. So we need to remove means what we should do here? In the place of cos square B, we need to remember the identity. What is the identity? Sin square A 1 minus sin square B. Be very careful with the angle, because cos square B is also what? 1 minus sin square B, because that is very important identity. Cos square B is 1 minus sin square B. Be very careful with the angle here. Minus sin square B you write as it is. And same way, in the place of cos square A, what you can write? 1 minus sin square A. Cos square A means 1 minus sin square A, and cos square B means 1 minus sin square B divided by cos square A into cos square B. This is one of the very important things you should understand here. Now we should open the bracket. That's called as a simplification. What is simplification? Open the bracket. Let us do that. So sin square A into 1. Sin square A. Minus is there. Write minus because plus into minus is minus. Sin square A into sin square B. So write like that only. Sin square A into sin square B. Minus is there. Minus into plus is minus. Minus sin square B, children, we have to be very careful with this also. Many of them will make mistake here also. Minus into plus. They write something like plus. That's wrong. Now you have to be very careful here. Minus into minus. Minus into minus is plus. And you should write sin square B into sin square A. I hope you are clear with the children. We just open the bracket and simplify it. And denominator will be written as it is, cos square A into cos square B. You can observe very carefully children. Sin square A into sin square B is there, sin square B into sin square is there. Here minus is there, here plus is there. What we should do here? It will get cancelled. because all of you know that it is minus here, plus is there. That is how it get cancelled here, that's the reason. And what is the remaining terms here? That is sine square A minus sine square B. Sine square A minus sine square B divided by cos square A into cos square B. Cos square A into cos square B. That is what your RHS. RHS we need to prove that itself, no? That is equal to RHS, right hand side. So that is LHS equal to RHS. So this is how to prove this problem here. It's one of the problem where you need to be very careful in understanding. What is understanding here? Especially the angles A and B. These angles are very important for you. Cos square B means 1 minus sin square B you should write. Cos square A means 1 minus sin square you should write. Why should you write? That's very important. Why should you write means you should observe RHS. RHS does not have cos square B and cos square A. So that is the reason you should write. It's not simply we are writing. Always whenever you do the sums, you should have that analytical way of thinking. Analytical way, reasoning. These are the things are important while solving the sums. Never do the sums mechanically. Just if you do mechanically, you will not be able to do this type of problems, children.